That might be different now. There you go. Interesting. Sorry for the people online who didn't get that. So an important constraint, as well as the size, is that other people will be involved in this project. And whilst they're willing to be technically adept with a computer, perhaps, they're not interested in learning what a C compiler is. That's too much information for them. And this is also a talk about over-engineering. So I am indulging my hobby and overusing my profession, perhaps. And let's eliminate the simplest solution to this, which is to push it with a finger. That would work. There's nothing wrong with that in terms of it would move the train. However, it has two problems that as a club we want to avoid. One is precision. The tolerance for these rails to line up is sub-millimeter. So getting that spot on every time with your finger is a bit of a challenge. And you have to do that while you're talking to the public. So this is a layout that you're exhibiting to members of the public. They're all talking to you. You're trying to demonstrate some feature of the railway network by operating a sequence. There's a lot of work to do as you're operating this. So fiddling around with a tray is not really what we want to do. We want to push a button and we want a motor to solve the problem for us. And then as a bit of an aside, which I'm not going to talk very much about, but the layout already has a CAN bus on it. So if you're not familiar with that, CAN bus is an industry protocol, common in cars, quite a few other applications. It's an electrical protocol that's good in high interference environments. That makes it really good for model railways, which have lots of spinning motors floating around and lots of people with mobile phones standing in front of them. And there's a bunch of model railway protocols that we use that build on top of industry standard CAN bus parts. So, how do we solve this problem with a motor? Here's the first solution I put together. And this is the product of assembling kit parts, essentially. This is the work of imagining that I could solve it this way and then going for standard parts and seeing how the solution would work. So you can see a stepper motor. You have to imagine that there's some piece of track on here that moves from side to side. This is a bench test piece. And you can count 1, 2, 3, 4, 5 boards, well, maybe 6. Don't count those two, they're only for this test bench. So there's 4 that we need to fit onto the model railway. And these two are standard CAN bus parts that are available to model railway enthusiasts. There's a club I belong to that people design these boards. One is for input to the bus and one is for output. So that's what those are. This is the stepper motor controller. It does the job of managing, I don't really understand stepper motors, but there's lots of voltages involved. It's very complicated, and it does that for me, and all I have to do is say step, 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 maybe thousands of times. That's something I can cope with. And then this is a Raspberry Pi Pico, which is running MicroPython. And the Pico is doing the work of gluing these 3 things together and turning it into the stepper controller that we want, that knows about 3 positions, knows which position it's in, and knows how many steps it needs to take to move to the position that you've just requested. And that's what this MicroPython hosting Raspberry Pi Pico does. And then, yeah, the test board is so that I can sit at my desk and just push buttons and test it without having to have a whole model railway and a whole CAN bus attached. So this is allegedly a simple solution. I look at that and I don't think that looks very simple. And my fellow hobbyists look at that and go, there's some problems with that. So there's a few problems we want to address. The biggest one is actually size. That's quite big. It's about as big as this thing that I'm holding. We've got to fit 3 of them onto the layout. I didn't mention that. There's actually 3 of those cradles that move on our layout. One that space is here, and one the space is here, and one is on another board. There's just about space to squeeze that in there. I haven't put a scale on this, but there's just about space. But the problem is, when you're transporting this around, everything you attach to the layout eventually comes off. So if the solution requires 4 boards that must be present, otherwise the layout doesn't work, times 3, that's a problem. Because one day, one of them is going to fall off, and then we don't have a working layout. And we spend a weekend telling people, sorry, it doesn't work, sorry. That's not a very good solution. And then the other thing going on here that's hard to see is software complexity. The MicroPython on here is very easy, that's perhaps unfair, is very approachable. I've met many model railway enthusiasts who are interested in learning MicroPython to achieve a thing on a model railway. What they can't see is all the software running on these boards. So these 2 are running PIC microcode, and this one is, I have no idea what it does, but it's very complicated and I'm not going to touch it. But if I want to change something on here, the only thing I can approachably change is this MicroPython. There's something about how it talks to the CAN bus that needs to change in the future. Maybe we need to integrate it with some other system. That's going to require a lot of complex software management. So how's that going to happen without me being present, or without someone with my skills being present? So there's two problems that I want to address: size and software complexity. I'm a software engineer. You can imagine where the software one is going. This is my attempt at designing hardware. It's my first attempt. And this is addressing the size problem. So this integrates those 4 boards onto one board that is a soldered whole piece, and therefore is going to be much more reliable on the model railway. We'll have 3 of these. It's got a Pico on it. It's got a CAN transceiver, no other microcontrollers. Solve that with the Pico in a minute. Then there's a gap here. I'm going to have to do a second version of this board where the stepper driver belongs. And the reason there's a gap is I was changing my mind about which stepper driver I wanted to use. So this is much simpler hardware. The physical part count is much lower. There's only one microcontroller. There'll probably be one here or two, but I can treat that as a black box. It will be more reliable, and it will certainly be more approachable to other members of the club. But the software running on the Pico is now going to have to be much more complex, because it has to do the work of the 2 boards that were talking to the CAN bus. There's a lot of CAN protocol that needs to be done. It's going to have to do the work of managing the stepper driver slightly more complicatedly. This is going to involve stretching the Pico a little bit. I'm going to have to use the PIO peripherals. We'll have to have both cores running, probably multiple tasks on at least one of those cores. That is actually very complex software. And how am I going to build that in a way that will be reusable in the future, or even understandable? MicroPython can do that. It's important to say that. However, to get MicroPython to do that, you have to use areas of MicroPython that start feeling a lot less approachable. You have to start exploring areas of the documentation which aren't as well trodden as the tutorials that you'll find on the internet. And you start finding areas of MicroPython where they say, well, you really do need to understand the C implementation if you really want to understand what this does. And that's a problem. Speaking personally, as a software engineer, I have some experience with this kind of technology. I'd choose C. But I think friends don't let friends use C these days. I think that's probably a fair phrase. And C is not the solution, because C only solves a very small part of the problem. I will also probably need a framework that I'm going to choose that's going to do some of the message handling for me. I'll probably need an RTOS that I'm going to choose. I've got a whole tool chain to select. I can select several tool chains if I want. That list of things that a model railway hobbyist has to understand if they want to change this is far too long. There's no way I'm putting that into a project that I expect other people to do something with in the future. So, where did I go? So I invented a programming language, and that sounds way less complex. I'll take debate on that point. The idea here is to write a programming language that feels like a modern programming language. It has a garbage collector. It has types that you can use, like dictionaries or maps, or however you name those kind of types. It feels like the kind of experience we get in a modern programming language. Feels a lot like MicroPython, but comes without the asterisks. It's designed for microcontrollers. The only domain it will ever be good in is microcontrollers. Every other domain, it'll be second class in some way. There'll be an asterisk. There'll be a, well, if you're running this on a PC, you have to do this extra thing, rather than the other way around. There's a lot of languages available for microcontrollers. The clue is often in the name. It's called micro something, or tiny something, or this kind of thing. There's a page somewhere in the documentation that says, here's the things that changed and that don't work like you expect. And that is disappointing, and actually quite hard for a non-technical person to understand. They're already trying to learn a programming language. What, you're telling me it doesn't work? That's kind of a strange message. I should disclose the name. I like the cheese. I thought it was kind of cool. It was also a short thing I can type quite easily. So what did I build when I built this language? I built a language that's dynamic. MicroPython, in my experience, is very approachable. People who feel they have enough technical skill or aptitude to approach programming like MicroPython. They're less keen on compiled languages. There's extra things to learn. There's a lot of different ways errors appear that are unappealing. So it's interpreted. You can just type on the REPL. I may be able to squeeze that into the demo. Might have enough time. And it will just run for you on the microcontroller. However, the architecture of it is to run a compiler first, and it runs that compiler on the microcontroller. So it compiles everything to a bytecode VM before it executes. And then the other side of this that's interesting from the point of view of using it on a microcontroller, sometimes it's interesting to ask the question, people are, so when I try and explain what I'm doing at the moment, people say, well, what's a microcontroller? It's like, it's a computer. That doesn't really convey the difference. And one of the important differences is it doesn't have an MMU, so it doesn't have a virtual memory system. So you can just touch any address in memory that you like. And that's where registers typically are mapped. Not always, but typically there are registers for the hardware that's on a microcontroller. And so the language provides constructs that makes that friendly. So you're not just typing random numbers in and trying to understand what they mean. You've got names. There's possibility for more help available. And the other thing it's got to do is handle interrupts. This is a big problem from the point of view of documentation and learning in other languages. Quite often, if the language's history is on desktop, interrupts are a kernel problem. The language doesn't have to think about that in its runtime. Quite deliberately, it ignores that problem. In Yarg, I want to fully support that. If you want to respond to an interrupt, you just write a function and tell it which interrupt it's responding to. And then a lot of languages, one of the things we've added to languages as an industry over the last 10, 20 years is proper or full support for multiple tasking in some way. That's a language feature, not an OS feature. So Yarg also has that. And it turns out microcontrollers are multiple cores these days. The Pico has 2, so of course you want to use them. I'm not claiming to invent anything here. I'm pulling ideas that I like and doing the work of putting them together. Where have I stolen my ideas from? Lua is a big inspiration. It's an awesome language that you can embed in other domains quite easily. And it has a great cooperative multitasking model. And it turns out, from my experience, a lot of microcontroller problems can be solved well by cooperative multitasking. You only want to do 2 or 3 things, you kind of understand when they're going to happen, and you don't want the expense and complexity of something more sophisticated. So I want to take the model they have for cooperative multitasking. And they also demonstrate, as well as MicroPython, both do this in fact, that a bytecode VM can be a high enough performance system for applications that we care about. I'm also inspired by Go. Go has clearly shows its heritage of being written by people who also were involved in C, in that it is quite machine-specific in interesting ways. So it has a type system that includes 8-bit, 16-bit, 32-bit, 64-bit integers, and you have to know about those things. And that's, I think, an appropriate model. I can get into the details of in a sort of Q&A about how Yarg handles it, but that kind of thing you need on a microcontroller. There are times when actually you need a 16-bit integer, and so the language should help you express that. And then Go also has a good model, there are many now, for preemptive multitasking. And once you've got 2 cores, you've definitely got preemptive multitasking happening. So I want to steal how that works. And then the big place I'm stealing from is MicroPython, which demonstrates that this works. MicroPython is an interpreted language that runs on microcontrollers just fine, thank you very much. There are plenty of applications being deployed where MicroPython is the underlying firmware. And the thing I really like about it is the ease of use. And it's kind of hard to express what ease of use means because this is programming and there are a lot of skills involved. But from talking to people and from my own understanding and experience, interpreted languages are more approachable as you're initially starting to investigate a problem. And quite a lot of projects start that way. It's like, this feels easy, this feels approachable, let's see how far I can get with it. Yeah, that's where I've taken inspiration from. What do you actually get in Yarg today? So there's 2 parts, and that's another key thing. I'm not really pushing hard on Yarg being self-hosting. It's probably technically possible, but a microcontroller is always a different thing to a PC or a machine with a virtual memory system. So I'm intentionally using that. So there's a piece of software that runs on your PC that's entirely to do with offline preparation of what you're going to run on the microcontroller. So it builds the file that you'll flash across, runs test suites that you might want to run on your software. You don't have to run those on the microcontroller if you don't want to. There'll be times when you want to. And in future, it's going to use those resources to optimize that image. So although I say there's a compiler that runs on the device, on the microcontroller, there's always going to be a better compiler available on a PC. So you use it if you can. I mean, I'm not writing that now, that's sometime in the future, but I want to architect that in. And then running on the device is the C implementation of Yarg. And actually that's also inspired from another source. There's a book out there called Crafting Interpreters, has a language in it, LOX, and if you read the book and then read the source code, you'll see I started exactly there. There's a lot of similarities. And that book just runs on a modern microcontroller. It works. So on the device, you've got the read-eval print loop, you've got an interpreter, you've got a compiler, and you've got the VM that executes your bytecode. And you know, it's interesting to think about what big and small means. I think of the Pico as a very generously proportioned machine. It's got 290K of RAM. That's a lot. That thing's got a lot more in it, and this thing's got even more in it. And it's like, okay, there's different senses of big and small. I was at a talk yesterday about embedded Rust, and there's now a RISC-V microcontroller available for a few cents that is 32-bit, and that's a lot more constrained than the Pico. But I'm thinking, that would be interesting. I really want to run Yarg on that. It's public, it's open source. There's a couple of us contributing at the moment. I have made a demo release. I haven't made 040. I really need to, because at the moment there's breaking changes on main. So there's a sort of a bit of a change. And it's a programming language. Know what you're getting into if you're using it before version 1. I will help. I will help. Okay, so it's time for a demo. I'm looking at the clock. I might be able to do the live demo. We'll see. It takes a bit of fiddling, so I might just cheat and play a video. But the two things I'm demonstrating with the demo, and the picture is of the thing here that you can't see, is interrupt response. It's just a function. And access to registers. Looks like C, actually, a structure, but you have this keyword place and this thing here, which is a memory address. So it's putting that for you in memory. And the thing that's perhaps not obvious, because it's sort of on a slide here, and I can't really type it all because it would take a lot of typing, but you can just type that into the REPL. So if you're building a microcontroller project and you don't have a driver for the one little bit that you really want because it's cheaper, faster, bigger, or whatever it is, you can just write it. And you don't have to go to another library or another language to achieve that aim. So I think what I'll do is I'll play the video. I get that to play. There we go. Now this is recorded live yesterday, so I feel I'm not cheating too much. I'm a big fan of live demos, but I think I'm going to be pushed for time. So what you see is me flashing over the firmware. You see the Mac complaining that the Pico is managing firmware for you. And what you can see in the corner here is my terminal, serial terminal. And I'm just typing print hello oggcamp, and it does it. It's like, okay, yep, that's cool. And then what you'll see in a second, really, yeah, I didn't thought through timing, but didn't think through size, so you can't really read that, but never mind. Come find me afterwards. I'll happily show you a demo. What we'll get to once it's done that is I've imported the code that presses the light, and then when I press firmly enough, which I get wrong, what you can see here is a little light coming on every time I press the button, and that is Yarg responding to an interrupt. So that's code you could type live if you wanted to on the REPL to respond to an interrupt and turn on an LED or do whatever you want. And it comes without asterisks. You don't have to worry about what you're writing in that interrupt code. You don't have to be careful about what you use or only use these APIs. You can just use Yarg. Yeah, I will keep going. And so if you want to see a live demo, come find me afterwards. I'll be around. Okay, so that is the project that I've built. If you've been listening very carefully, there's an important thing I've not done yet, which is finished the actual module that goes on the model railway project. My fellow club members are being very tolerant, and there are other projects like the viaduct and some other things that are taking similar amounts of time, so I'm hopefully not delaying how we exhibit this, but I do actually have to finish that, and that's my goal between now and the summer. The language needs support for characters and strings. It's got some basic support. You can already use a Unicode string, but that comes from the origins in LOX, so I need to think about what we need permanently there. Actually, I can tick this off. So I'm using some old slides, and I've done PIO. That was necessary actually to do the LED decorations that I was doing for Christmas. I was using one-wire addressable LEDs, and the good way of driving those on a Pico is with the PIO module. So Yarg supports that now. And then the other thing I need to do is start broadening out what it actually runs on. So Pico 2 would be an obvious choice. The W version, so you need to spin up a Wi-Fi network. I've got some thinking about how that will work. And the interesting one from my point of view is spinning up the RISC-V cores. So I absolutely don't want to be tied to any particular CPU, and RISC-V is really interesting. There's lots of interesting products coming. It seems to be quite an interesting space. So I want to make sure Yarg can target that. And then why not ESP32? They're very popular. The main reason I started with Picos rather than ESP32s is I could find the documentation easier. So I could get low-level documentation much more easily. I don't think there's any philosophical difference between the two things that would prevent it working. So yeah, that's me. So yeah, I'm writing a programming language. It's at version 0.30 now. It'll get to 0.4 or 0.5 over the next couple of months as I get that stepper motor finished and get some other projects going. If you want to follow along, I doodle some notes in my email every month. The QR code will get you to all of this stuff. If you're more interested in model railways, the group I'm a member of is called the South London Area Group of this national organisation, the Scale 4 Society. We're badly named. It's a very historical thing. We're actually based in Leatherhead, so if you're in the Leatherhead area, feel free to come and chat to me. And if you're not, go check out the national website for the particular scale of model railways that we work in. And if you want to check out the language, go check it out on GitHub. That's where it is at the moment. I like the spending Microsoft's money on CI. So we have some CI that does stuff regularly, and I get that from GitHub. So if they want to give me that for free, I'll take it. Cool. Thank you very much. I will happily take questions. I will try and remember to allow people to get the microphone. Best for the people online.
Hello, this is amazing. I'm going to start using it.
Thank you.
Did you come across Forth in your experiments? Because there's a project called STM8eForth, which has the similar pattern where the compiler is actually on the microcontroller, and you just define the code in the REPL. And I just found that really interesting when I first came across it. And then Python's kind of different because it's not compiled, it's truly interpreted. But in your language, it looks like you do ship a compiler on the microcontroller and compile the code in real time. Yeah, so did you come across Forth?
I did, and I think people who implement Python say there is some compilation stuff hiding in their implementation these days. As a language, though, it is interpreted, and that's true of Yarg as well. Forth is really interesting, and I didn't cite it as an influence because it encourages you, the language appears to encourage you to think of things as a stack, which is exactly how the VM works. That's exactly what it is. But it turns out that doesn't work so well as a programming model for us using it. So it suits some people. It's kind of like Lisp. It suits some people, but generally more wider applications, it's a bit niche. So I haven't stolen from it too much. But yeah, it's kind of cool. It demonstrates that this stuff works, right? You can run compilers on very constrained devices.
Great stuff.
Thank you.
The examples you gave were very insightful from a systems programming kind of point of view. So how I allocate a register, for instance. But kind of how do you, that doesn't look to me like code that you would want to request that your fellow kind of train engineers are writing, because they're, or is it, or am I wrong on that? Like, I guess it felt to me that this was at the C end of the spectrum rather than the Python end of the spectrum. And I just wondered what kind of, could you give us a kind of hint at how Yarg behaves when you're coming from that end of the user experience?
So I think I would encourage people who are willing to approach Python to start talking to registers. One of the things I hope to add to the language is a nice bit field type to make it nice and pleasant to do rather than shifting stuff around. Not got that yet. So it does read like C in that area, which is kind of unfortunate. But where it's different is if you're typing a single line statement at the REPL to define where a register is, and then your next statement is to flip the bit that you think does the thing, and it does, you're done. And if it doesn't, well, the worst case is you push reset and you try again. And with C, there's a lot of stuff around achieving that cycle that you have to learn and understand. And people tell you you're doing it wrong unless you do understand all that stuff. And I think that's an important difference. So yes, it does read like C. That's semi-deliberate because a lot of the examples are C, so why not have things that you can cut and paste? Yeah, I think it is different once you actually try experience using it. Any more questions?